In this lecture, we will be talking about metamorphic rocks. Let's do a quick recap. The three types of rocks are igneous, metamorphic, and sedimentary. Igneous rocks come from magma or lava. Metamorphic rocks come from rocks that have been changed due to heat and or pressure. Meta and morph are two words that mean change and form. Sedimentary rocks form from sediments. So now we will take a look specifically at metamorphic rocks. Metamorphic rocks are rocks that change due to temperature and pressure increases. Meta is a root word meaning change, and morph is a root word meaning body or form. So a rock will change its body or form due to heat and pressure. Metamorphic rocks can form from igneous rocks, sedimentary rocks, or even other metamorphic rocks. There are two types of metamorphism. The first kind is contact metamorphism. This occurs when magma will come up through rock and the surrounding rock will then heat up and morph. So the surrounding rock is in direct contact with the magma, therefore it morphs. The second type is regional metamorphism. This metamorphism occurs over thousands of square kilometers due to tectonic activity. An example would be two tectonic plates colliding. This could form a whole mountain range. The whole mountain range would be part of the regional metamorphism. So here's a picture that shows contact metamorphism. Here's the magma, even coming up. The lightly shaded region just outside of the magma, that is where you're going to get contact metamorphism. When this happens, sometimes you can get other chunks of rock that are included in the magma. When this hardens, they would be included in the igneous rock. Here's an example of regional metamorphism. Now this is a cross section, so if we cut the earth in half, we would have two tectonic plates. As they push together, the rocks, because they're under high amounts of pressure, will start to bend and fold. This would be a regional metamorphism. We have two ways we can classify metamorphic rocks: foliated and non-foliated. Foliated means the mineral grains are flattened and are lined in parallel bands. This is caused by pressure pushing the minerals flat. Some examples, we have schist, gneiss, and slate. My first picture, I have a picture of gneiss. So here we can see the white and the black layers are parallel to each other. In the second picture, I have a picture of slate. Slate looks like one solid color, but it will break along these flat planes. Before a rock is metamorphosed, mineral grains may be in all different types of directions. When you add pressure to the mineral grains, it'll cause all the mineral grains to lay flat. This will give us our foliated texture. Imagine you hold a pencil upright on a desk, and you have your hand at the top of the eraser. Imagine pushing down on the pencil. What would happen? The pencil would lay flat. This is exactly what happens with our mineral grains. You add pressure to the mineral and it will lay flat. The second type of metamorphic rocks are non-foliated rocks. Here there are no bands, just crystals. This is because the heat and pressure cause the mineral grains in the rocks to recrystallize. Two examples we have: when quartz sandstone has heat and pressure added to it, it will turn into quartzite. The next example is limestone. When you add heat and pressure, it'll turn into marble. Notice how both examples do not have any layers or bands. This is because they're non-foliated. So rock number 1, is this foliated or non-foliated? This example is foliated because there's layers in it. This is slate. What about rock number 2? Is this foliated or non-foliated? This will be non-foliated because there are no lines or layers. This is quartzite. What about rock number 3? Foliated or non-foliated? This would be foliated because there are layers, parallel layers. This is an example of gneiss. And last, rock number 4, is this foliated or non-foliated? This would be non-foliated because there's no layers or bands. This is an example of marble. This is a picture I took of Sidling Hill off of I-68 in Maryland. These rocks are folded in a U-shaped pattern. This would have been a regional metamorphism because plates collided, and under great pressure, these rocks folded into a syncline. A syncline is just the U-shaped feature of the rock. This ends our lecture on metamorphic rocks.